knowing, probably figuring out by now.
Oh, but like the structure, she's not a tough grader, so
Right.
no.
Okay, so there's this thing called LU decomposition of matrices. L stands for the lower, U stands for the upper. Okay, and notice that there's ones down the diagonal of the L, and these are 2 means row 2, column 1, 3, 1 means row 3, column 1, and so on. Okay, and what the teacher is trying to show you here, and this is really super important here, is they're going to give you a matrix like this. And I don't know if you get a note sheet or what you get, but they're saying there's a way to decompose this matrix on the left into this business on the right. The matrix 1, matrix 2.
Okay.
Okay, now how to do that? Well, here's how to do that. So they give you the formula. I don't even know how you do this otherwise. I mean, it's basically a nightmare to do, but they're saying U11 is 2. That one right there is 2. U12 is 1. U13 is the 3. So they're basically telling you like the first 3 entries in the matrix become the first 3 entries in the upper one. Do you see that? 2, 1, 3 is U11. I'm gonna try these right here, or these right here, which are these up here. That's like the easy stuff. Is that clear or not?
I got a little bit confused.
Okay. So they're fundamentally, do you understand that a matrix A can be like if you were to multiply these 2 matrices together, if you multiply these together, you get back the A.
Okay.
Is the idea. And they have this form. There's 3 numbers down here, one's down the diagonal, and then what's called upper triangular form on the right here.
Okay.
Is that okay?
Yes.
Okay. So like you have to decompose this. You have to be able to decompose this. And the only way you can do it is with this formula. Okay. So what they're trying to tell you is from the original form. See how this is really A on the left here? This is matrix A. This is A right here.
Yeah.
See how they're the same? They're saying like, here's how you get the entries. U11 is 2, U12 is 1, U13 is 1. They're saying like these top 3 entries are the top 3 entries of the existing matrix.
Okay.
Okay. So, well, how do you get the rest of them? Well, L21 times U11 is 4.
1, 1.
So here, let me show you. This is equal to this.
Okay.
So your teacher makes an equation. She says 4 equals L21 U11, like that.
Okay.
And then we can do it again here. This box equals this box here.
Okay.
So
Okay.
4 equals L21 U12 plus U22. So notice if you found L21, you could use it in here. Like once you find some of these variables, you start using them. Let me go to a different color here. So here's this one, and then here's this one. So 2 equals L31 times U11.
Okay.
Now, keep in mind here, you already know U11. Like I know this looks really bad, but you already know U11. U11 is 2. You can use that here to find L21, which is, and then you can use that one in here to find this one. And that's what we're doing. But I'm showing you how to set up the equations. Okay, so here's another one. Circle equals circle. 5 equals L31 U12 plus L32 U22. Is that okay? Kind of.
No, but how do you multiply it, or do you just keep it like that?
No, we're going to solve this. I mean, I'm just setting up the equations. I'm just setting them up.
Okay, okay.
But like, do you see you set the element equal to the element?
Yes.
Like 7 equals that. I'll have to switch to highlighter or something else because I'm running out of colors, of course. So yeah, so this 7 equals this over here. So 7 equals L21, U13 plus U23. Okay. And then let's do the red one. So this 9 equals all this over here. So you have 9 equals L31, U13 plus L32, U23 plus U33.
Okay.
Is that okay?
Yes.
Great. So now we can solve this. So we already know though, we already know that U11 equals 2. That's from the top row here. This equals that. So this is, and then U12 equals 1 and U13 equals 3.
Okay.
So we have those values. So this doesn't, it's not as bad as you think because U11 is 2.
Okay.
So we can now solve this first equation. So let me, I can move these down a little bit. So again, you can see that this is really 2, L21, 4. So solving this equation, L21 equals 2. 2 times 2 is 4. Same thing down here. We know U11 is 2. So we know that 2 equals L31. L31 equals 1.
Okay.
Okay, so now I'm not sure where to go from here because I never do this by hand, but we've got some of the values. Okay. Let's look at this equation. Let's see where U13 comes in. U13 is there. Okay, so we can go to, and this is, it's hard to know like where to go next. So this was, we did 1, then we did 2. So we're gonna go over here 3 next for this one. And the reason is because we have L21. L21 is 2. We just calculate that over here on the left. U23, no. Oh, I'm sorry. U13 we have from the beginning. That's 3. So we can solve this for U23. U23 is 7 minus 6, which is 1. Okay.
Okay.
That's good. It's really good because we obviously need all these, but we need this one especially down here. So in this it looks like L31. We don't have that one. Okay.
But is this the homework question, or is it
No,
one?
this is not the homework. This is the notes. This is the
Okay.
notes.
Okay. Okay.
Okay, and we can go to the homework question right now if you want, but it's gonna be very much similar. So what do you want us to do?
I was just asking, so I
Yeah,
can.
yeah, you're the customer though. You tell me. You're like, hey, stop. I'll stop.
No, no, no. Continue.
Okay.
I just want to understand this.
So L31 is 1. We calculated that. L13 is from up here. That's 3. That was a given. L32 we don't have. I don't think. Okay, so we're not looking good here. Let's go back. Do we have you? Oh, so we should have gone up here next. That's where I made the mistake. We should have gone up here. Because we have L21. L21 is 2. U12 was given, that's 1. So we can then solve this for U22. The teacher in class should have talked about an order to solving this. So U22 equals 2. Because 2 times 1 is 2, you subtract it, you get 2. All right, U22 is 2. And that helps us with this next one, 3, 1, 1, 2. So we should have gone down here next to the green one. L31 is 1, U12 is 1, L32 we don't know, but we know that U22 is 2. And so we can solve the system now.
Yeah.
This is 1, subtract 1, that's 4. L3, 2. L3, 2 is 2, because 2 times 2 gets you 4, plus 1 is 5. And then that makes the next bit a lot easier. That L3, 2 we're going to use down here.
Okay.
And then U2, 3 is 1. So we should probably supply in order 4, 5, and then 6. Okay. Plus U3, 3. All right. And then you've got 3 plus 2, that's 5. Subtracted of that's 4. U3, 3 equals 4. So the reason we did all this is because we want these values.
Okay.
We want L21, L31, L32, and we have them all now. 2, 1, 3, 1, L32 is right there. We wanted U1, U12, U22, all the same. And so you just put them in, and your final answer 1, 0, 0, 1, 1, 1, and you go grab those values. L21, 2, L31 is 1, L32 is 2. Same thing over here with these. So the first 3 come right from here, 2, 1, 3. Sorry for all the scrolling. 0, 0, 0. So we need U3, 3 is 4. That's on the screen here. We need U22 and U23. So it's 2 and 1. So if you were to go to a calculator, MATLAB, you would be able to substitute these in and get, like, if you were to multiply these two matrices, you would get the original.
Okay.
Okay. Now, my guess is she covered this exactly the same way I did in class. So I hope seeing this a second time is helping, because it's a lot of work. But now we can actually do question 1 for an A.
Okay.
And you're probably noticing this class moves fairly quickly,
Yeah.
but nothing we can do about that. So let me grab from the notes again. Just to kind of make a couple snips to make this readable. Boom, we got that. All right, so there's your matrix. And then here is your kind of your setup. Hopefully you get a reference sheet for your exam. This would be a good thing to have. So right off the bat, U11 equals 2. U12 equals -1, and U13 equals -2. Does that look right to you? The top row is these numbers, or these 3 letters is the top row.
Okay.
Okay, so the next thing is -4 equals L21 times U11. And we already have U11, it's 2. Okay, so that means that L21 equals -2. Is that okay?
Okay.
Yeah. Good. Now we're gonna do the same thing for this next -4. -4 equals L31 times U11. So I'm using this -4 on the bottom here, this down here.
Okay.
Okay, so we already know that U11 is 2. So we know that L31 is -2.
Okay.
Okay, now you look for your next equation. You're like, okay, do I have L21? Yes.
Yeah.
Do you have U12? Yes. So we're going to use this equation to solve for the next one. So 6 equals L21 U12 plus U22. 6 equals L21 is -2. U12 is -1 plus U22. So this is 2, subtract U22 equals 4. And then you start looking around, what do I have next? Do I have that L21? Do I have L21? Yes. Do I have U13? Yes. So we can use this equation. So like the order is, if you're like kind of snaking through this, it's like that. That's how you do it. So we're using this equation here. Again, I'll do that at the end. So we're doing and so back to our matrix, we're letting this one on the right here equals the 3. So it's 3 equals L21 U13 plus U23. L21 U13, yeah. Okay, and L21 is -2. U13 is -2. So we can solve for U23. It ends up being that U23 equals -1. All right, and again, like this is in your notes, we're gonna now go to this one right here. So I'm gonna, and that equals the -2. So we'll work that out here. -2 equals L31 U12 plus L22 U22. L31 is -2. U12 is -1. L22 we don't have, but U22 we do have. That's 4. It's a little more sophisticated to solve. This is 2, you subtract 2, that's -4 equals L22 times 4. So L22 equals -1. And then we're almost there. The last one, I should be snipping this since it's your teacher's handwriting. So let's try that. So the last one here is that this 8 equals all of this mess over here on the right. So L31, which we have, yes, L31 is -2. Very easy to mix these up, -2. U13 is -2 plus L32, wherever that is. Yep, that's what we're solving for. U23 is -1 plus U33, which we don't have. I missed something here. 32 L32. Help me out. We didn't get that one. We used it there. Oh, I did the wrong one. Okay. We're supposed to use this one first. No, we did that one. Did I write the wrong one? Oh, this is L32. That's why that's a problem. Okay. You can see how easy it is to make a mistake, which I just did. I just subscripted it wrong. So you got to be really super careful here. That's why we have computers that do this, but not in your class. Okay, so this is 4 plus 1, that's 5. Subtract U33 equals 5. Okay, so this is close, so close to the final answer here. The final answer for your LU decomposition is right here. We just got to put the numbers in. I have to go back and look for each one of them. So L21 is -2, -2. All right, L32 is -1. U11, that's so the top row is the same as your original. So that's the 2 minus 1 minus 2. 0, 0, 0. The U33 is 5. All right, so we've got to get U22 and U23. U22 is 4 and U23. So there you go, -1, 4 and -1. Like that.
Yeah.
Now, if it were me as a student, I would go to the internet and do an LU decomposition calculator and make sure this actually matches. It looks right, but I don't know.
Okay.
Okay, so let's go on to part B. Actually, well, Yeah, let me, we'll know in a moment, I guess. All right, so here's part B. So there's a way to solve this matrix with the LU decomposition, but you have to set it equal to a right-hand side. So this is like, it's like there's three equations, three numbers on the right there. Well, hopefully that's been kind of shown in class. Now the way to do it, and here this may not make much sense, but we'll do an example here, or we'll do this one. So you set AX equal to B, and this is your B right here. And what that means is if you take LU X equals B and Y equals UX, then LY equals B. Okay, so here's how that works. It probably doesn't make much sense. You take the L, okay, and you multiply it by your what's called your vector of your X's. So these, we'll call this X1. Well, your teacher uses Y, so let me use her notation. Y1, Y2, Y3 equals, and in your problem, it's -1, 13, and -6. And what this corresponds to, if you think back to your L is right here. You're taking this matrix right here, which I'm going to grab, and you're replacing L with it. Let's see if I can just move this around nicely. Yeah, there we go. Okay. And so what happens here is when you multiply row and column, which is how you multiply matrices, you get Y1 equals -1. That's this row 1, 0, 0 times this column.
Yeah.
Okay. Then the next one's a little more work because it's not, but you take this row times the column. So you get -2 Y1 plus 1 Y2 equals 13. But notice that you already have Y1. You already have Y1, -1. Negative times -1 is 2. The Y2 ends up equaling 11. And then you do the same thing for the third one here. You go -2 Y1 minus Y2 plus Y1 Y3 equals -6. And you use your values here. You're like, okay, I got Y1. Y1 is -1. Y2 is 11. So you got 2 minus 11 is -9 plus Y3. So you add 9 to both sides and Y3 equals 3.
Yeah.
Is that okay?
Yeah.
Then you have to do it for the other one, which is probably equally frustrating, but that's the way it goes. So hang on a second here, 4, 12, 12. Why did the teacher do the other one? Oh, okay, I'm sorry. So I apologize. So you need these results here. So you take the results from this one, which is -6, -6, 3. And then you write your X1, X2, X3. These are your actual variables you're solving for. And then you take your U matrix here. So I'm going to grab the U matrix. Again, none of this is ever done by hand, except in this class. But it's kind of neat, I guess. I mean, I don't know. But it's the same thing here. You take row times column, you get your answers here. So I need to go back and solve this original system because this is not looking right. So give me just a moment here because our first answer is a fraction. 5x3 equals 3 is going to end up equaling 3/5. Let me just solve this by hand or with computer real quick to tell you.
Okay.
Are you following this or is this totally overwhelming?
Like I understand how the steps go, but like sometimes I forget what's next.
Yeah,
Like,
it's a lot.
I just need to
Yeah,
practice.
it's yes. 2, and then right hand side. What was the right hand side? -1. 4, -2, 8.
I want to ask you, how would you able to give a lesson tomorrow?
Yes.
As
Yeah,
a
so I did mess up somewhere here, and I couldn't even tell you where, but yes. So, all right, the we need to do. There's a mistake somewhere. I have no idea where it is, but because the answer actually ends up being nights. Let me see if this one's correct. 4x2 minus 1 minus 1 equals that. Yeah. Okay. So there's a problem. I don't know. We'll have to find it. What do you want us to do? Do you want me to search for it? Do you want me to just give you the correct LU decomposition? There's a mistake somewhere, I guess is what I'm trying to say.
oh,
And I don't know where it is. Because the solution to this is nice. It does work out nice.
okay, okay. But like, how do you have the solution? Could we
Well,
compare?
what I'm going to do is look for an LU decomposition calculator so that we can get it. Because as you saw, and then just check that. So let's do that here. Okay, so here we go. Let's go back to the original matrix. That's probably where the error is. There's some sort of a little thing here. So 2, 2, -1, -2, -4, 6, 3. The problem with these calculators, they don't show you any steps. They just give you the answer. Let's take a look here. All right, so the L that they got is very different than the L that let's see. Oh, hang on. -2, -2, -1. Okay, that looks right. 2, -1, 4, negative. Okay, so there's the issue. That's supposed to be a 3. I don't know. And that's why we're off. So okay. Good news is that was this one. -2, -2, 1, -1, 0, 1, 2, -1, -2, 4, -1, 0, 0, 3. Okay. Okay, so there's good news there. The good news is that this goes to 3. All right. Um, and so you have 3x3 here equals 3. So we're taking this bottom row times this equals this.
Okay.
So x3 equals 1. This next one isn't going to work. Why is it going to work? All right. So there's a mistake up here. Y1 equals -1. -2 y1, that's -2. Okay, there it is. So that's supposed to be 15. No, it becomes 2. -2 y1 plus 1 y2 equals 13. So we're taking this second row times this column equals the 13, but y1 is -1, which means that this becomes 2. You subtract, you get 11. That looks okay.
Okay.
Did I not put 11? Oh, I didn't put 11 in here. That's why. I didn't put any of these numbers in here. Well, that's just terrible. Okay, I see the issue now. The issue is I didn't put y1, y2, and y3 in here. So
Oh,
and that's why that's why the error is coming. So we got -1, 11, and 3. All right, now it should work. So second row times the column here is 4x2 minus x3 equals 11. x3 is 1 from here. So you add 1 to both sides, that's 12. You get 4x2 equals 12. So x2 equals 3. That's what we're expecting. And then take the first row times the first column, 2x1 minus x2 minus 2x3 equals -1. So 2x1 minus 3 minus 2 times 1 equals -1. So this is -5. Add 5 to both sides, that's 4. 2x1 equals 4, x1 equals 2. And does that work with what I said? It does. So all that works to find that x1 equals 2, x2 equals 3, x3 equals 1. There you have it.
okay.
Okay,
Okay.
on to number 2. Um, Number 2 here, use Horner's rule to evaluate the following polynomial. Go your work. Okay, so here's the polynomial. And they're giving you some sort of formula here. So we need an example because we don't do it this way. So I believe your instructor, yes. Instructor has polynomials. So we'll look at those.
Yeah.
Use Horner's rule to evaluate polynomial at 1, -1. Oh yeah, okay. Where you only get one example of this. Why is that? Okay. This is weird. Okay, so we're gonna look at the part. We're gonna look at the part, just this part here, which is the X part. And we're just gonna focus on what's in parentheses for the moment.
Okay.
And this is written out of order from what your instructor does. So I'm gonna first thing I'm gonna do is just reorder it. So -1 plus 3x plus x squared minus x cubed plus 2x to the 4th plus 4x to the 5th. And it's all squared. We'll deal with that at the end. Okay. All right, so here we go. The way Horner's rule, this is Horner's rule. The way this works is you go to you take everything that's got an X in it. You look at all the stuff with an X, and you probably saw this in class where the teacher would like underline it, but you basically factor out an X from everything. So you get X 3 plus X minus X squared plus 2X cubed plus 4X to the 4th. And then you factor out an X out of all of this stuff here. That's in parentheses. Well, sorry, not that. All of these get an X factored out. All right, so the way it works here is it's -1 plus X, 3 plus X times 1 minus X plus 2X squared plus 4X cubed. So I'm taking an X out of the things in red. And I'll do that again here. -1 plus X parentheses 3 plus X parentheses 1 minus X parentheses. So I'm taking an X out of all of these. So it's 1 plus 2X plus 4X squared. Like that. And these are all, it's all squared, but I'm trying to hold off on that. Okay, and then we keep going. We got to do it again. We got to factor an X out of these two. -1 plus X parentheses 3 plus X parentheses 1 minus X parentheses 1 plus X. And then this becomes 2 plus 4X. And then to figure out the number of closed parentheses, you look how many you've opened. There's 4. 1, 2, 3, 4. And then you square. So the idea is that this is much easier to do for your multiplications because you can just put 1 in for X. I guess I don't really know why this is such a big deal, but the idea is that there's these coefficients called B that you're getting each time. Does that sound at all familiar to you?
D?
B like boy.
No, does
Okay.
not.
Um, yeah, so there's the way teacher they're calling 1, 2, 3, 4, 5. Okay, so this is B4. This is B3. This is B2. This is B1. And then this last thing is B0 is the idea. So B4 is equal to 2 plus 4 times 1, which is 6. And then B3 is equal to 1 plus, and then your X is this right here, which is 1 times the number you just found, which is 6. So that becomes 7. Your B2 is 1 minus X, which is 1 times the 7, which is -6. Your B1, you're back to this 3, so it's 3 plus 1 times -6, which is -3. And then your B0 is -1 plus 1 times -3, which ends up being -4. Let me do the sanity check. 6, 5, 5, those cancel. -1, that's not right. When you put 1 in, you get 4, 6, 5, 6, 9, 8. Why are we off? Okay, 4 times 1 is 6, 7, 1 minus 1 times 7 is -6. 3 plus 1 times that, -3. -1 plus 1 times that's -4. Why is this off? So there's an issue here. It's not working out the way it's supposed to, because we know the answer. We know the answer when you put 1 in. It's 4 plus 2 minus 1 plus 1 plus 3 minus 1. So some sort of mistake here. 3 plus x minus x squared plus 2x cubed. And then factor out 1 minus x plus 2x squared plus 4x cubed. And then factor an x out of that. 1 plus 2x plus 4x squared. -1 plus 1 plus factor 2 plus 4x. 6. Huh, I'm not seeing it. 5 times 2, 14. 3 plus 14 times 2. Okay. All right. So there's a mistake somewhere. Not sure. This is the general idea, though. Maybe it's over here. 2 plus 4x. X is 1. That's 6, right? That's 6. And then you take 1 and you add it to that. So that's 7. 7. 1 minus 7 is -6. 3 plus 1 times -6 is -3. -1 plus 1 times -3 is -4. Okay, so it's B0 is that. Maybe there's another piece. Maybe it's B0 equals something plus something. For 2, 5. -49, you get 40, they got 49. B0 is what it is. Okay, well, there's a mistake somewhere. I'm just not tracking it here. -1 plus 3x minus x cubed plus 2x squared. Fourth. Okay, I don't suppose you see it. I'm not sure. So the idea though is that this number, because we know what it actually is when you put 1 in, is you get 4 plus 2 minus 1 plus 1 plus 3 minus 1, which ends up being 8. 8 squared is 64. And then you do the same thing for this piece over here on the right, which probably should have done that one first. Let me see if I can do that one real quick because it will work out a little bit nicer. And so let's try that. All right, so let me grab a snip of this. Okay, here we go. So again, we should rewrite this 2 minus y plus y cubed. So it looks like this 2 minus y 1 plus y squared, like that. There's really a 0y cubed here, which we might as well throw that in. So let's go plus 0y squared, 0y like this, plus, get rid of this one here, plus y squared. And then we have 2 minus y, 1 plus 0 times, I'm sorry, 1 plus y times 0 plus y, like that. Okay. And then we put in x equals -1. So this first one here, I'll have to switch colors here again. This is B 0, 1, 2, B2. So B2 equals 0 plus, I'm sorry, your y is -1. 0 plus -1, which is -1. Your B1 equals 1 plus -1 times -1, which is 2. And then your B0 is 2 minus -1 times 2, which ends up being 4. Is that what we expect it to be? So -1 cubed minus a -1 plus 2. This ends up being -1 plus 1 plus 2, which is 2, not 4. What is going on here? Okay, -1, -1 there times that. 1 plus -1 times negative is 2. 2 minus -1 times 2 is 4. I don't know, Hamad, there's something going on here. The notes aren't very clear, although their example seems to work out pretty nice. So maybe we can look at that next time again.
Okay.
Not really sure. Taylor series will go a little faster here. That's three should go pretty quick. 4's got an example. So I don't know. You tell me what you want to do here, but let me go ahead and stop the recording.